Hey, Stephen here from Brew Supply. Today I want to show you how I manage fermentation temperature using our temperature control kit and in conjunction with our ETC controller. So I'll start with the temperature control kit. What it is it's a 120 volt solenoid on a 3-foot cord, and it controls the inflow of water to help you to regulate the temperature of your fermenter. So what we have it hooked up to is a 1.5 inch tri-clover fitting, and as well there's a garden hose fitting for the inlet side. Now we chose garden hose fitting for the inlet because it really is easy to hook it up to a faucet, and I like to use these high pressure braided water lines that you can get. These are they're like $8 or something at Home Depot, and they're for washing machines. So it's really easy. You can hook it up here to the faucet, or you can do what I've done here on the right of your screen. You can see there's a ball valve, and I've got a male garden hose fitting attached to it. So it's really easy for me to connect, disconnect, add a fermenter. You know, you can split it. So what I've done is I've split my inlet water at the source, and just made it a little bit easier for me to keep my sink free. So when I'm brewing and whatnot, I can just keep a couple fermenters off to the side that are fermenting. The way that it works is, and I should say this, as long as your water temperature is 1 or 2 degrees colder than the desired fermentation temperature, you're good. You can use your source water. I live in a colder climate, so that's not a problem. I'm doing a double IPA in here, so my fermentation temperature is at 67 degrees, and it really doesn't take much, just a little trickle of water to manage the temperature, you know, because my inlet water temperature is still probably under 60 degrees Fahrenheit. What I have here then is this is a modified version of our temperature control kit, because I'm working with an older fermenter that we used to sell, and the water runs through a coil. It's a stainless coil, and the outflow of water just goes into my drain here. Now I'd recommend securing the outflow of water, but I've also got the water throttled down so much I just let a trickle of water run through. So the solenoid is then plugged into the output of our ETC controller. And this is why I like this ETC controller so much. It's really a versatile piece of kit. It doesn't just regulate your brewing temperatures, but it can also regulate your fermentation temperatures. So, you know, you've got a cooling output, a heating output, and a pump output. So when I'm done brewing, this controller goes right back into use, you know, for my fermenter. Now my temperatures are fairly stable. In other words, most of the time it's above 67 degrees in here, so I only need the cooling side of the controller. But let's say you needed heating and cooling. You're brewing in a garage, gets a little bit cold at night. Well, these fermenters all have ports, and our elements are designed to go right inside the fermenter, so you can have an element in the cone and in the port, and that's why we design our fermenters with a couple different ports. Our Unibroid Pro systems, our Unitank Pros. You can leave those elements inside, and you can even fire those elements if you need to manage the fermentation temperature on the heating side as well. So it's real simple. This is one of our power cords, and this being all 120 volt, this is just a small little brew system. Or a small fermenter, I should say. You can plug this into the element, and then plug the other end into the heat output, and now I've got control, heating and cooling. And because I only have a 600 watt element inside this fermenter, it really doesn't, I don't have to worry about it cooking the yeast. So the yeast is fine, the fermentation process is fine, everything works as it should, and it manages the temperature in as tight of a tolerance range as I want. And I can set that differential on my ETC controller. So that's just another reason it'll automatically switch between heating and cooling as needed to maintain a tight control. You want to be careful with overlapping circuits when you're doing something like this. So you want to have a temperature spread that's enough to account for the overshoot. So I usually set it around 1/2 degree over and 1/2 degree under because there's always a little bit of residual thermal effect when cooling. It can cool down past 67. It might cool down to 66.5 or so. And so you don't want your heater kicking on every time it just gets to 66.5. It's only going to be there for a minute or so. So you can really kind of dial in your differentials here with this controller. So that about covers it using source water. But what if your water temperatures are too warm and you cannot actually use water for your fermentation to manage your fermentation temperatures? Well, in that case, we put out a video on showing how to use a water chiller, just a common water chiller. In this case, I was using a 1/4 horsepower chiller. So you can, in the comments below, I'll put in a link to that blog post and video. You can have a look at that if you needed to design your own system that way. There's a few other options in the brewing industry. You can get glycol-based systems. Those are a little bit more expensive than water, which is free. And even if your water's metered, you're never really going to use that much water when you're flowing. So mine is always just at a bare trickle, and when it turns on, it only turns on for something like a minute or maybe 2 minutes before it shuts off. Another option is to use a pre-chiller option, but pre-chillers often don't work very easily. They involve ice and ice melts, and you're doing this during your fermentation time, which is a week or longer, right? So I think that I've covered everything here in the video. Thanks very much. I hope that you can comment on the video below, and thanks for watching. My name's Steven. This is Brew Supply.